In 1513, an Ottoman admiral named Piri Reis compiled a naval map of the world. Drawn on gazelle skin and decorated with ornate compass roses, it was a standard, functional piece of medieval cartography. But in 1929, researchers discovered a geographical anomaly hidden along the document's bottom edge. The peninsulas and inlets precisely drawn in this section match the northern coast of Antarctica. Officially, Antarctica was discovered in 1820. This map records its features 300 years before the first recorded human sighting. This document details the subglacial topography of the interior. It depicts inland mountains, bays, and rivers as they exist beneath miles of modern ice. Current geological records indicate that Antarctica has been covered by a massive ice sheet for millions of years. In 1960, the United States Air Force Strategic Air Command investigated the map's accuracy, comparing its ancient coordinates to modern seismic data. Their analysis confirmed that the map's features align with the seismic profiles of Queen Maud Land, rock that has been buried under ice since the arrival of the first humans. This creates a physical contradiction. A 500-year-old map containing data that requires 20th century seismic technology to verify. Piri Reis's own naval logs clarify the origin of this data. He explicitly noted that he did not survey these southern lands himself. He instead compiled his worldview by merging 20 different source maps gathered from various royal archives. Some of these source documents dated back to the era of Alexander the Great, originally drawn by unknown cartographers from an even earlier period. The Piri Reis Map functions as a data trace, a medieval copy of lost ancient knowledge that had been preserved in fragments. Because the subglacial data is verifiably accurate, we are forced to choose between two conflicting conclusions. Hypothesis A suggests if humans mapped an ice-free Antarctica, the ice sheet is drastically younger than believed. This means freezing occurred within human civilization span. If true, current models for climate tracking and geological dating use a flawed baseline. Hypothesis B assumes our geological dating is correct. If the ice is millions of years old, a civilization capable of global navigation must have existed millions of years ago to map it. Both options are equally disruptive. We must either discard our understanding of Earth's climate history or acknowledge a human presence in the deep geological past. The existence of these ancient source maps suggests that human progress may not be a simple linear climb from primitive ancestors. If high-level navigation existed in the distant past and then vanished, it implies that civilization is subject to periodic cataclysmic interruptions. Global events could erase the bulk of human knowledge, leaving behind only the kind of fragmented records Piri Reis merged into his 1513 map. If our history is built on these surviving traces, then our current era is one of many attempts to rebuild what was lost. Mainstream academia typically dismisses the map's accuracy as a series of coincidences, as the alternative challenges the foundations of archaeological study. Validating the map would require reconciling modern ice core dating with a human presence that predates our current records of migration and technology. But scientific debate does not change the physical reality. The rock formations drawn on the map still exist, precisely where the ice hides them. The timeline of our species remains uncertain. If the map is accurate, a significant portion of the human story is still waiting to be uncovered beneath the ice.